So the project was looking at how floodplain deposition is currently modelled within GBR catchments. Currently, floodplain deposition accounts for a large portion of sediment lost within the catchment, within the paddock to reef models, and that means that it's very hard to find cost-effective landscape repair projects in the mid and upper catchment areas because the modelling is saying a large portion of that sediment is deposited on floodplains further down the catchment. The model that was used to make those predictions within the paddock to reef models was developed sort of over 20 years ago, and since then we've got really great high resolution information such as LiDAR data and detailed hydrodynamic models, so we can more accurately classify floodplains and also predict how water and sediment flows down channels and across floodplains. It produced a better understanding of how flow and sediment moves down channels and onto floodplains, and so how often floodplains are engaged. Once floodplains are engaged, how much water and sediment moves across the floodplain compared to staying within the channel margins. And this has helped us provide recommendations to the paddock to reef modelling team about how they can adjust their floodplain deposition models to more accurately reflect how water and sediment has moved through the catchments and towards the Great Barrier Reef. So we identified 17 case study areas across the Great Barrier Reef catchments in a range of different sort of land use and landscape settings, and we did some pretty detailed analysis on the channel and floodplain morphology from LiDAR data and some detailed hydrodynamic modelling to see how water flows down those channels and out onto floodplains. Based on that, we'll be able to test some of the assumptions in the paddock to reef models about how much water and sediment flows across floodplains and make those recommendations about improving the model over time. Rivers and floodplains across Queensland are really, really diverse, and there's a huge diversity of channel depths and widths and channel capacities. So trying to have one model that's able to accurately represent all that diversity of river landscapes across the GBR is going to be really, really difficult. So we need to start developing river classification approaches that can identify those diversity of river and floodplain types and make modelling recommendations specific to each different type of river and floodplain to more accurately represent the processes that are occurring in those specific river types. One of the things we also investigated was how floodplain engagement can be used as a tool within landscape repair projects. By slowing down water within river channels and getting more flow and sediment out in the floodplains, we can actually capture more sediment on floodplains further up in the catchment. So that's something to be considered along with your typical riparian and stream bank management programs as another little lever we can pull within landscape repair projects.